Are you aggravated by leaking components, leaking gearboxes? Is leaking a problem at your facility? Today we're going to try to help you guys understand why this may be happening. Oh, hey, this is Scott from Sumitomo Drive Technologies, and today we're going to talk about seals. So when we're talking about seals, when you want to look, when you load in something in Google, you just don't want to type in seals. So we're going to talk about industrial shaft seals, and in our case, how they relate to gearboxes. And we're going to go over some seal designs that people ask these questions all the time. What is a taconite seal? What is drywell? Labyrinth plate, labyrinth covers, gamma. What's the difference between Viton and nitrile? What's the difference between nitrile and silicone? And the chemical makeups. That's a lot of stuff to cover. We could be here for days, but we're going to try to do it in minutes. So it's going to go fast. So pay attention. So industrial shaft seals, you have shafts that are exposed, so we have to have a way to keep the oil, grease, lubrication in and keep the contamination out. The other type of sealing design is when you're separating two different types of lubrication, which in our case, most gearboxes, we call these a drywell. Typical drywell design is basically almost like a drum-looking apparatus or component inside of the gearbox that may rotate with the shaft, or it may be stationary and the shaft is rotating within the drywell. Typically the shaft is just rotating within the drywell. But we cannot allow oil to mix in with the grease. That's a big problem. Really, when you're talking about is the seal that I've selected or the seal that we've used, is it going to be effective in my application? We have to have we have to be concerned with speed. We have to be concerned with the environment, the application, the temperature, the ambient operating temperature. Surface speed is critical when we're talking about seal selection, as well as shaft material and shaft condition. But when you're talking about seals, it sounds simple, and it's usually one of the cheapest things in a gearbox. But man, it is very, very important to have that right. So we're going to talk about radial shaft seals. We're going to talk about cassette seals. I've got a whole bunch of cool stuff here to show you guys. First things first, let me show you guys what a collar looks like. So some people call these wear sleeves, and we call them shaft collars. And this has a particular finish on the ID, as well as a plunge ground, which is the machining term for the OD. And this finish on the OD and really on the ID cannot be directional. In other words, the machining term is it cannot have a lead. When we talk about leads, we're talking about the grinder really moving actually across the face of the component. So when we finish our collars or our shafts, the grinder is coming in, and it's what we call plunge grinding. And this way there's no lead. If there's a lead, that depending on the direction of the shaft, the oil can find that lead and it'll begin to trickle. We see this quite often when gearboxes come back. Somebody tried to repair it themselves and they just didn't understand what has to happen with that, especially with the shafts. Very important. This guy here is called a speedy sleeve. This guy's still in the original packaging. You cannot store these any other way. They will get damaged. And what this guy does, he's going to repair a damaged surface, typically on a shaft, not on a collar. If you're putting this over a collar, that's not a good idea. You should replace the collar if at all possible. We use these. It's only for repair, and it's a Band-Aid. But these guys are awesome. If you can't remove the equipment, they have to be ordered specifically for the shaft and the seal diameters. If you don't know that, give us a call. We don't use anything in most cases that are outside typical seal availability and shaft diameters. But these can be custom made. It takes a little time, but these are great if you have a severe leaker and you can't get the gearbox back. But keep in mind, this is temporary. It's not a permanent fix. This is a permanent fix. We talked about surface speed, the type of lubricant you're using, the application, the seal design may vary from that. In a lot of cases, ours, the seal design does not, but the protection of the seal or the bottom bearing, which we talked about earlier with the dry well, that may change. Very important to protect those top seals from contaminants. I like to use a hood, a seal hood that goes over the top. It looks kind of like this guy. This is a clipper seal, but a seal hood looks very, very similar to that. It has a taper to it, rotates around, contaminants that drop down are flung off away from the seal during operation. Just don't go and hit these with a 5,000 PSI pressure washer. That's just not a good idea. Or a hammer, ever. But by the way, this is a clipper seal. This is a type of seal that's used on an end bell of a motor behind the fan to protect the gearbox when it's stopped. This is behind the fan. The fan is out here. This is behind the fan. When the motor is running and you hit it with whatever you need to wash it down with, that's usually good enough to keep contaminants out. But during the stop, this is a really good idea to have during static, where the gearbox is sitting still and you need to just don't point your hose into the fan cover. That's just never a good idea. You don't need to do that. But one of the biggest things that we see with seal failures, when there is misalignment or your application has heavy radial load and you just may not have compensated with a more robust seal design. Even the seal materials can be helpful if you have high radial loading. So what we're talking about with radial load and seal lip deflection is there's a large amount of radial load vertically. We see this quite often, but the seal cannot compensate. The lip cannot compensate enough by itself. Speed. So speed, as I mentioned before, speed equals temperature. The selection of the material, which we're gonna give you guys some good ideas about the differences between the materials. You want to move up to a better grade material or more tougher material than standard. So if you're running at a higher speed, your surface temperature is going to be higher, so you may want to move into the next grade of seal for us, which is either polyacrylate or Viton. Viton has a higher temperature than nitrile, doesn't go as low as nitrile, but indoors Viton seems to serve most people's needs very well. Nitrile rubber, we're going to talk about the materials between nitrile, #1 seal that we use, Viton, really the #2 seal that we use, and silicone seals, which are pretty rare. And silicone seals are, they have a really low temperature that they can run at, and they also go all the way as high as Viton. But the difference is that you're talking about with silicone seals versus Viton is silicone is not as tough. It's a softer material, and in the dynamic movement of a shaft, which we got a little bit of radial movement, that's natural with the clearances that we have in the bearings and just the machining of the shaft. Silicone is just not going to hold up like Viton seals. But in freezer duty applications where you're flash freezing and you're negative 100 degrees or whatever that is, then yeah, silicone's probably what you need in your application. So nitrile can go down to negative 22 degrees, which that covers pretty much everything in the United States, and then it can go up to 210 F. But keep in mind, this is surface speed and startup speed, and it's very important that if you're starting something that's rubber, which is what seals are made out of, that you don't start it at the high rate of speed. I think the recommendation is probably below 60 degrees. We think that's a little aggressive, but you want to start these things slow to get that rubber warmed up as well as your lubrication, and that seal will last a lot longer. Hey, check us out on our other videos. Hit us up on social media and make sure to subscribe to our YouTube channel. Thank you. All right. What else? What else do you need to know about seals? And yeah, this and this and that. And I mean, it's like a dance class.